Good morning, everybody. I was pleased to see that it was 2004 when you really began to frame this sort of discussion between energy companies and meteorological or climate organization. Because, in fact, when I take my position by 2003, I joined in the summer the crisis management for the heat wave, and then I discovered the importance of this strong relationship between climatologists, meteorologists, and crisis management in a company. And I think I will highlight the second point that Laurent has said yesterday in his presentation, is that also we have to be careful on how information from meteorological information is able to circulate within the company, because at that time, maybe you remember that we had an issue about the temperature of the river. The information was available for the people who are following the demand side, but not for the people who are working on the production side. It was, of course, in two different offices very close to each other and managing the crisis within EDF. So we realized that we have to intensify that. Later in 2003, I remember being called when I was in Japan, being called by someone of Meteo France to keep in contact and in touch with the crisis management for a flood on the Rhone River. Then I realized that it was really important that we have this sort of work you are doing here, putting together the people of Meteo and climate and the people of companies. This is, I believe, one of the rising issue we do have, as it was already mentioned by Mr. Trockel. This is a rising issue. I think we are just at the beginning of our collaboration on all these questions. If I may, I would like to reframe a little bit from our point of view all what we said about our need as electricity company. I am not an energy company, and I don't know anything about other energy company need, but as an electricity company, I think we are involved in this question for a while, that it was mentioned with Météo France in France, but also in the UK with our EDF Energy is also involved in this sort of question. Of course, demand side it was important, and demand side was from the beginning heating and light. And we don't forget light. I think it's as important as an influence on electricity demand as heating. And for us, one of the questions I will have for you is that if we will have, from the beginning I thought that we will have a shift with this average climate change and global warming will be translated in a shift from winter to summer consumption, from heating to AC. But if it's not, it's an average, meaning with very low temperature in winter and very high temperature in summer, and it will not mean the same for us. Just a question about climate, and I'm not sure this is captured today in your climate provision. So first, light and heating. Tomorrow, AC. That is my point of view. I was in a meeting with other company in Saturday in New York about adaptation to climate change, and I will be back to that later. But AC is still a big issue for a lot of electricity companies. That means that summer is as important as winter for us. So light, heating, and cooling. But at the same time, and this will be slightly different from the two previous speakers, renewable is not new for us. And renewable uncertainty is not new for us. Hydropower is a renewable, and there is high uncertainty on it. Of course, it's look much more easy to predict than wind or solar. This is not the same time scale, but this is unpredictable. How are we to manage what is happening with snow this year? This is a huge question for us. Is that snow to vanish and evaporate suddenly, or is it to melt with a waterfall and rain? How are we managing that? Just to have an idea of the volume of snow we had on France, is that in Corsica, which is not often like that, but for the first months, Corsica was able to have 70% of its own electricity needs with hydropower, which is not used. So the volume this year is huge. We need to manage it, but we need also to know if we will have a drought or not. So this is crucial to be able to have this view on renewables. So yes, now we have wind and solar, and these are two different things with other needs on forecast and more precise need on forecast. But we develop within the company, you mentioned it, Madam, we develop some model on water and hydro prediction because we need it. We need it because we don't have people on the dams. That means that if we presume that there will be a flooding, we need to have alert. And I will be back to this question of alert. None of you mentioned it, but this question of alert is key for us. And it's not only key for extreme event, it's key because we need to be able to have the people informed and in right position to prepare the installation or to be facing anything which can happen. So it was the past. The past was with hydro. In fact, I learned about weather forecast when I was head of hydro. Then I discovered that I received alert. And one of the questions I always had to answer is, do you agree to have false alert? And this question of false alert is a big question because it's a question of money, of insurance. And this is a question which will be a rising one. I will be back to that about crisis management. This is a rising question. What are the level of false alert we agree to receive from you to be able to manage correctly and prepare to events? That's the same for prediction, but this is not as accurate as false alert. So first it was about demand side, then for production side it was first hydro, and today it is more about solar and wind, and everybody wants to have more precise view of what will be the wind tomorrow and what will be the wind in the next hour. We need to be able to have more reliable prediction to be able to know what sort of backup we need to have or not about wind farms, but it is also how are we dealing with the reservoirs that are this only electricity storage that exists today, which are reservoirs. How are we able to keep our reservoir at a good level to be able to manage correctly at a better cost the electricity production? But as it was mentioned by Mr. Troquel, it's also about cooling systems. And of course it was the case, but nobody knows. That's why we developed within EDF a model which is very important, which is about prediction on flooding and on flow and temperature in all our facilities. And I don't have the exact figures, but this model was able to save something like 1% or 2% of the disponibility of the nuclear fleet by 2011. Because remember, 2003, everybody spoke about cooling issue for our nuclear fleet. By 2011, it was a more dry year. It was a more hot year globally. But the result was nobody heard about anything because we were able together to have this model, which were able to give us the way to cool our facility very easily. Very easily not, but it's adaptation and water management. And this is important to have the correct information coming from your data to provide our model. And this is one of the points I think Laurent mentioned also, is how are we able to connect? Because we do have very complicated model to transform meteorological data within production data. And we need to be able to connect that. And as your model are becoming more and more complex, or are also. So this is why this sort of conference is very important, because we have to know how to make that discuss together. I am not anymore a mathematician, but I know that to put the model together is not so easy. I like to go to a point which was mentioned, but I want to insist on it. It's about downscaling during an event. It is very important to think that we have to know what will happen when we have an event, whatever it is, flooding, heat waves, whatever the event. We need to be able to downscale, not only on our facilities, but on the consequences our facilities may have on the life of the community. Because, and this is bring me to climate. Electricity is, in a way, it's what we said in that meeting. It's in a way sort of, we can say, the blood of our society today. We need it for everything, everywhere. That means that electricity is key, and I'm not saying energy, I'm really saying electricity is key to the resilience of community facing extreme events. And that means that we have to think of our infrastructure in the way they are able to take advantage, to support and develop the resilience of cities. There is a very interesting report that I suggest you read from IPCC on cities and climate change. And in it there is a chapter on electricity. And it's really about how electricity is part of the resilience of the community. But to be part of the resilience of the community, you must have a good downscaling about what are the way you can prepare the infrastructure in the case of extreme events. And then the extreme events, you need to have an idea of what it could be. And once again, downscaling and climate is key to be able to prepare. So adaptation for us is first adapting our crisis management. And for the crisis management, once again, we need to have whatever the event is, even if it's something that has nothing to do with a climate or a meteorological event, like, I don't know, a pollution. This is an event. If you have a pollution on a river, you need to know what the flow will be, if it will rain or if it will be wind. So you need to downscale for an event, whatever the event is. So adapting crisis management, as I say, is about alert and false alert. We need to agree on false alert. I remember listening, I don't know if you listened Bloomberg just before Sandy, but when I listened to him just before Sandy, he said something like, I asked the utilities to remove some of that transformer to be sure that they can be put in place back after the hurricane. Okay, but if the hurricane will have been 10 kilometers from there, who will pay for that? There is an insurance and cost issue on the false alert. And we have to work, I think, on what it means for you and for us, to agree that we can accept a percentage of false alert and which one. And this is not so easy. I think that our people who are in our R&D are in the middle of this question with you, because, of course, the operational wants to know for sure, and of course there is uncertainty. But the question of uncertainty is a question which is key in this evolution of climate. We need this alert to anticipate the preparedness of our squad, because we have really squads which are able to answer to any extreme event. By 2000, we had a hurricane in France, and the result was more than 2 million people without electricity for more than 2 weeks, and we say never, never, never again. And now we have squads which are really organized to reduce that impact. And for the last storm we have, I think that the people were out of power less than 1 week, mainly 3 days or 4 days, which has nothing to do with the 2 weeks we experienced in 2000. So this is very important to have an understanding, because to be able to have to prepare and pre-install the squad, we need to do where, when, and what. So this is what the alert is about. It's also about what you mentioned now about hardening our existing facilities. When are we to install more system to cool our facilities? When is a good time to do it? What are the good scale of fall to protect them? Which are all that? We need to have an idea of it, and I think it will be an iterative process, because you are not really precise in your view of the future climate. But we need to harden our existing facility. we also need to develop new sort of facility. I like to say to talk about that. We develop what we call key P-ware for hydro dam, which are able to project in the water during a flooding in another way that the traditional wares. And I think we have to rethink all of new facilities, thinking of other way. I like the example of wind farms that can be laid when you know that will be a storm. You can build stronger and stronger wind farm, or you can build wind farm that you can lay down and they wait for the end of the storm before being able to produce again. We do have this sort of facility in La Guadeloupe. And to end, I would say that in our discussion in New York with other companies, we realized that we need something more. And I put that on the table. I don't know if you will answer that, but I think that we have to have a shift in our mindset, the way we are dealing with the changing climate. I give you this example of the wind farm. I illustrate that saying that we must change from ought to read. The French here knows very well this little poem of Jean de La Fontaine, The Ought and the Reed. We have to shift from ought to read. This means that we have not to build and harden facility. We have to rethink the facility differently. But maybe this is the same for you. Maybe you have to find other ways that looking on past data to predict the future and to give us a view on the future climate. It's something I try to bring within the company, that the decision-making process cannot be done by looking in mirror to the back, but we have to reinvent a new decision-making process, and it will bring us to new sort of infrastructure, which will be more resilient to what will happen to us, because we don't know. As I said, I understand that we will have a global warming that for me means at the beginning that we will have a shift from winter to summer consumption. And if not, well, how are we working with that? So just this question that we use for some security and safety issue, which is why not to think the unthinkable and to have this new approach even in your climate forecast. Thank you very much.
Thank you very much, Madame Nahon, for this excellent and illuminating talk, especially for us meteorologists, and have a view of the real life out there and see what the energy people really need. And we have some time for some questions, please. We have microphones there. If you can approach the microphones, introduce yourself and ask a question, please. Do we have any questions? So I would like to just ask one myself then. In terms of false alarm, and I understand that this is, you say it's a very critical issue for you. So at the moment, just trying to understand what do you do with predictions? Do you take a conservative approach and try to, not use the forecast much because you don't rely on it, or do you actually a bit progressive and take some chances with the forecast?
I think we take the forecast for what it is, with its uncertainty, and that we decide what to do according to the uncertainty which is related to the forecast. But that's what I am saying. False alert means that you will ask people to move. You will put material on position, and it will have a cost. So when it's occurred once a year, it's not an issue. But if we have extreme events every month, it will be an issue. That's what I want to mention. And this is an insurance issue. How are we paying for this insurance? It will have a cost. When I mentioned that we changed the way we are operating after 2000, that means that we decided to have mobile diesel, and we decided to have a squad of people who are able to come inside the zone where there will be a storm, we'll say 2 hours after. That means that we use helicopter, we use truck, because you cannot come inside that sort of zone so easily. So we have to pre-position all these people and material, and it has a cost. And of course, if the event is coming, this is part of the cost of the event, but if not coming, it will have a cost. And that means that today we need to be more precise on that, because if, once again, it's secure once a year, it's not an issue.
Okay, thank you. If we have another question, very little time. Otherwise, we can move to the next speaker. And thank you again, Madame Nahon.